I'm Frank from Revolution Systems, and I wanted to talk about some of the things that I see as a consultant and that people miss all of the time that are very easy to do. A lot of times in talks and in tutorials, everybody's focused on, here's this complicated cache key strategy. How do I make sure that when I bust this cache value that I have current data on my site and all the places that I'm using it? And people they throw up their hands. That's too complicated. I don't want to deal with it. I'm just going to maybe throw a little more hardware at the problem, or I'm just going to kind of pretend that my site is as fast as it needs to be. But there are some really easy things that people miss all the time that can give you 10, 15, 20% better performance that are 1, 2, and 3 line code changes that are in the documentation, but they're small little footnotes in the documentation and people don't always spot. So instead of just telling you which ones to do, I built a little demonstration app and ran tests against it to show exactly how much performance some of these things impact. So I built a very simple 3-model system with a category. I used UUIDs for the names. I generated a random number just to simulate some data, a couple of paragraphs of lorem and some text, just to fill up the database so that it wasn't, a 5 megabyte database that is going to get cached into RAM. So our rando objects are associated with categories, and then each rando has between 1 and 20 randomly sub-rando items. So I did this all on my laptop here. It's Django 1.6, Python 2.7, Ubuntu 12.04 with Vagrant. Like I said, I used UUIDs and random integers. We did some big paragraphs of text just to bloat the size of the database. So we've got about 100 categories, 400,000 rando objects, and about 2 million sub-randos. It's about 1 gigabyte of data on disk. Some simple class-based views. We list our categories. We list the data of the details, where I grabbed 50 random randos, show the data of those randos, and I've created both with and without login versions, so we can see the difference between anonymous users and logged in users. Now, it's not very pretty. This is, I optimized the performance of the site here by not using extraneous markup or CSS. So it's not very pretty at all. It's not even Bootstrap. It's just HTML. And so this is what a category listing looks like of unique names, very unique names. This would be a rando detail page. So we have some links off to some other rando items. And then we have a rando detail. So you can see just random data just to fill up the database, just to give us something to play with. So then I beat the hell out of it with Siege. So this is a 2-processor virtual box running on my laptop, and I pushed it up to a concurrency of 100 and beat on it just to see exactly what kind of performance. So we need a baseline. We need some really bad performance to show how to get to the better performance. So I tested it with debug equals true. That gives you a whopping 17 transactions a second. Now we know that debug is bad to use in production for performance reasons. It turns out it's actually really bad, for security reasons. It turns out it's actually really bad for performance reasons because just turning debug off got us 120 transactions a second, up from 17. So that's a pretty base. I'm not caring about performance. I just want to throw this up on the web and have people use it. So one thing you can do that is literally 3 lines of config is to cache your templates. Everybody misses this. The default template loader, by default in Django, goes out, checks the disk, reads in your template, parses the template, and then does your request, right? Presents it to the user. So caching the templates got us 20 more requests a second for 3 lines of change. So instead of using this here at the top, which is the default that you get from Django's global settings, you just add the cached loader there, and you get an extra, quite a bit of extra performance. So when you're deploying this, a lot of times people are still using like one single settings.py file, and you're definitely going to want to split up into using multiple settings files. Because if you use your cache loader locally while you're developing, every time you make a change, you're going to be going, why am I seeing any changes? You'd actually have to restart run server manually every single time, or it's going to use those same cache templates. So you only want to use this setting in production or staging or QA, and not locally for your local development. Another one people don't seem to pay much attention to, even when they've been told about it a lot, and it's pointed out quite a bit, is caching your sessions. Django's default session backend is to the database, and people are like, well, it's a small amount of data, it's not going to load, it's not that important. But that's an extra select statement on every single request that your users hit. A lot of times nobody's even actually attaching any session data to it. This is just used for authentication. So it doesn't matter if you lose your cache, if your memcached would die or you restart. It doesn't matter, the user's gonna have to log in again is the only consequence, but you can get quite a bit better performance. I've actually missed this even in a large production site, and a few months later, the performance seemed fine from the user's perspective, everything was good. You come back a couple months later, and what's my largest table in the database? Whoa, why is Django Sessions so large? Oh, it's got 2.5 million entries in it from all the users that have got it here. Remove that, turn on cached sessions, and boom, there's an extra 100 milliseconds of performance. So all you have to do is change your session backend from the default backends. Hopefully you're probably already caching more expensive to generate data, but if you're not, you need to set up your cache and then switch on cached sessions. Now you're not hitting the database on simple requests. One thing people don't think about is a lot of times you're hitting this even on directed template pages, pages that aren't even using the database. You're hitting the database to just check to see if the session is still active. If for some reason you do actually use session data, you can use cached DB sessions, which will only write to the database when you've actually changed something about the session data. The rest of the time, just deal with your cache. So turning on cached sessions got us 155 transactions a second. So about 10 more transactions a second just by removing that. And these are on really simple apps. This is just a listing and a detail view. These are not complicated applications that we're getting. In a more complicated application, you're going to see slightly less performance because most of it's going to be masked by all of the application logic that you're using. But it was one line of configuration change to get this extra performance. Before Django 1.6, this one was harder to do, and so people avoided it. It involved, if you were using Postgres, you had to use PG Bouncer or PG Pool to pool your database connections so that you didn't make a new database connection on every single request to the site. But Django 1.6 now supports this out of the box, which is great. Makes it super easy, except by default it's turned off. And most people probably don't realize that by default it's turned off. So you have a new parameter to your database's config called conmaxAge, which tells Django how long to keep these connections open. But by default it's set to 0, so it's not used. So moving to 1.6 doesn't really give you any immediate performance benefit there. But setting it to even something as simple as 5 minutes gets you quite a bit better performance. So on our local, we got 25% speed increase because these are simple apps. They're doing simple things, but a lot of that time was just connecting to the database. And these are easy things to forget. Your app works, it seems fast, you hit it, it's fine, this is fast enough, but we changed one little line of settings and got rid of a whole bunch of performance problems that we now can seem a whole lot faster to our users. Are you using all of your machine? A lot of times, so you've got Nginx, maybe memcached running, you got DjangoCon or some other WSGI process on a server with 4 cores. How many WSGI processes should you have? The answer is 2, because you need to reserve or allow 1 CPU core to be Nginx, 1 to be your memcached, and you use the other 2 as your WSGI processes. So a lot of times I'll see people running an 8-core system, but they have 2 WSGI processes and maybe memcached on another system. They're not fully utilizing their box that they're paying for. So you'll want to make sure that you match that up. Things that are going to be running constantly and getting a lot of traffic, a lot of CPU time, need to have their own core to fully maximize your box. And similarly, if you've got a box with 8 cores and you have 20 WSGI processes, you're probably killing your performance because you're swapping, your context switching in and out of that CPU, these various WSGI processes. You think you're getting better performance because you can handle more requests, but you're really not. You would be actually faster to reduce the number down. So you can get a lot of performance out of things that aren't Django, actually. We're Django developers, so we focus a lot of time on the code we're using, but you can get a lot out of the performance out of the front end without changing a single line of Python code. So in all my benchmarks so far, I've been using a stock standard Nginx config inside this vagrant. All I did was turn send file on, TCP no push, TCP no delay, set some hash sizes on server names. That isn't important for this particular case, but if you're virtually hosting lots of domains, that actually becomes a big part of performance. And I'm turning the server tokens off because there's no reason to be saying, hey, I'm Nginx, hey, I'm Nginx, I'm Nginx, I'm Nginx on every single request. So doing this got us another 13% of performance because it's just not doing slow TCP things that by default are safe, but are really based around problems with older browsers that really aren't even in use anymore. If you really do need to support IE4 and things way in the past, you might want to experiment and make sure that these things actually work. Windows 95 probably doesn't play with this very well, but I don't think any of us really are that concerned about it. If you are, I'm sorry. Maybe you should find a different job. So by far, reducing database queries, caching your data smartly, not hitting the database are the big wins on performance, but you can cheat because you can make your site feel a whole lot more performant than it is. Users can feel 100 milliseconds performance difference. You know, you start thinking about a site takes 3 seconds to load, 4 seconds to load, you think about seconds. But you can feel 100 milliseconds. So simple things like combining your CSS and JavaScript. I get very sad every time I see a site that has 10 style sheets and 20 JavaScript files. Because even in a best case, you're talking about 100 to 200 milliseconds if you're on a really fast network next to the server and a good modern browser on good modern hardware, then you're just costing the user for no reason because it makes your deployment a little bit easier. So if you combine those things into one request, one CSS, one JavaScript, you can save sometimes as much as 500 milliseconds, which is very noticeable. If you do that, you essentially can mask where your servers are located on the globe. That basically gets rid of the cost of the speed of light around the globe, in a sense, to the end user, because they don't have all those extra requests going on. It feels that much faster to them. So, my absolute secret trick that is not a secret trick. I've talked about it before, lots of people mention it and bring it up, but very few people do this, and it makes the world of difference, and I really encourage you to go and do this to your sites. Far future expire headers on your static assets. Everyone misses this. I don't know why. It's a little harder to do in places like S3 because you have to muck about with Boto's config and set things directly and write a little bit of code. But it makes a world of difference. And your far future headers, they don't have to be that far. You don't have to worry about the problem of what if this user caches this and I've made a CSS change 4 months ago and they're not seeing it. By far future headers, I'm talking about maybe 5 minutes. Most of the times, if you think about a typical user session, they come to your home page, they look around for a couple of seconds, they click on something, and that's the next request. Well, maybe that's 20 seconds later even. They're then asking your system for 10 different CSS files and 20 different JavaScript files. Did you change? 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 No. You know, a lot of times executives and developers are worried about what happens there at the deploy at the expense of the 99.9% of the time that you're not deploying. So if you simply set them for 5, 10, 15 minutes, your site can feel twice as fast. And you didn't do anything but set some headers. But Frank, I'm lazy. Why should I do all of this? My site works fine. So I'm going to bribe you. If you can improve your site by 10%, it means you can save 10% of your hardware costs. Right? That's a free month of hosting. But maybe you're not driven by money. So do it for Django. Right? Your site, if anyone knows that it's built with Django, reflects on Django. So do these small, simple little things that probably won't even take you 20 minutes to do all of them. Do it even on your home personal blog and your little hobby projects, because it makes Django seem faster and better.